Okay, so we got a question right here. A student is designing a night light for a child. When switched on, the night light should come on brightly and its intensity should then gradually decrease to zero. The time taken for the light intensity to decrease to zero should be as close to 10 minutes as possible. The time must not be less than 10 minutes, right? The diagram shows the student's design. The student uses a light emitting diode LED and a resistor R. The LED stops emitting light when the potential difference across it falls to 1.4 volt. The student assumes the LED has a consistent resistance of 340 ohms. Capacitor with the following resistance capacitor with the following capacitance are available: 0.5, 0.51, 0.54, 0.58 and 0.6. Further, determine which capacitance the student should use. Resistance of R is basically 860 ohms, right? So I can see an important point here. It says the time should be close to 10 minutes but not less than 10 minutes, right? So we can note that time should be basically close to 10 minutes and not less than 10 minutes, right? Not less than 10 minutes, right? Okay, so we have been let me draw a diagram first so that I can explain it easily. So here we have a diagram, right? This is our supply, which is 12 volt. Here our capacitor comes, right? This is our wire going here. This is our dot, our one more dot over here, resistor, right? And this is our LED, light emitting diode, right? So this goes right here. This is R, this is LED, right? This is capacitor and this is our power supply. Now we know that once it basically just switches off if it reaches to 1.4 volts, right? So if it's less than or equal to 1.4 volts, it's gonna be closed, right? We know that the resistance of basically the LED is 340 ohms and the resistor resistance is basically 860 ohms, right? 860 ohms. Okay, so there are two methods to do this. I'm going to do the first method in this video, the second method in the other video. The first method is basically using V is equals to V initial E exponential basically minus T by RC, right? And this formula is only used for capacitors, right? Capacitors, right? Just remember that. So we are going to use the electric potential for this area because over here it charges up, over here it basically discharges, right? And we see there's not only a resistor there but it's also LED, right? So basically they are like dividing, basically they're dividing the capacitors volt, right? So we're going to use the potential, basically the electric potential formula, right? Using potential divider formula, potential divider. So the potential divider formula is basically V1 is equals to R1 by R1 plus R2 times Vs. So V1 is basically voltage, right, across resistor, right? And basically this one is voltage for supply, for the of power supply, of the source or power supply. And this resistance R1 is basically the LED, right? LED's resistance, right? And R2 is basically the resistor, right? Okay, so we have done that. Now we're gonna substitute the values, right? So we have the power supply. We need to find the V1 is basically V initial, right? The voltage across the resistor, right? So we need to find the voltage across it, right? How much voltage is going here, because we know that how much voltage is gonna go over here before it stops. We need to know how much voltage is also going over here, the V initial, right? the V initial it has, the capacitor it has, right now. So V initial is basically equals to 340 by LED resistance, and R1 is basically 340 plus the resistance which is 860, right? So, and times the source, which is voltage of source, which is we have 12, right? We have 12, right? Because once it charge is completed, this will also have the 12 volts. So you can similarly say the same thing, right? It's just the voltage of the source, right? From where it's the voltage is coming from, you know. So you get your answer as 3.4 volt, right? So now we have to use this formula. V is equals to V naught E minus T by RC. We have V naught as 3.4, right, E, and we have, yes, we have volt as 1.4 before it just closes down completely. This is our initial volt. This is our that volt which is of the LED, which is gonna be basically, if it reaches here, it's gonna basically close or stop emitting the light. The time is basically 10 minutes times 60 to convert it into basically seconds, right? So 10 times 60 is basically converting it to seconds. And the resistance, remember this resistance is the total resistance across the discharging circuit, right? So basically there are two, right? Resistor resistance and LED resistance. So basically we're gonna write the total resistance for both of these, because 340 plus 860 is 1200, right? 1200 ohms, right? So basically we have 1200, right? And capacitance we have to find, because he asked us to determine the capacitance, right? So capacitance, once you have done solving it, you will get your capacitance as 0.56. okay, this is your value. Now we are stuck with 0.54 F and 0.58 F. Now we have to decide which one we have to use. We can't use the less one because he asked that it should be close to 10 seconds but not less than. You remember the statement, right? Close to 10 minutes but not less than 10 minutes. If you're gonna use this one, it's gonna be less than 10 basically minutes, right? You have to use the higher one to be, you know, close or greater than 10 minutes. It doesn't have any restriction about the greater one, but he has the restriction that you shouldn't go less than 10 minutes, right? So we are gonna use this capacitance, right? So this is your answer.